Transcription and translation. Transcription is how DNA becomes RNA, and it's followed by translation, which is how the RNA makes a protein. This happens at the ribosome. DNA polymerase is an enzyme that will catalyze the production of a complementary RNA strand off of the template DNA strand. The RNA should look like the other half of the DNA that would be matching up with our template strand. So here's an example of a DNA template strand, and here's the RNA that would match up with it. Notice how the first one codes for start and the last for stop. Each 3 letters, or 3 nitrogen bases, is called a codon. The RNA does not contain T, thymine. Instead, it will have U, which is uracil. That's circled. See? So that was transcription, and now we're moving on to translation. The mRNA, which has been created during transcription, will look as follows. There it is. So this travels to the ribosome, which is outside the nucleus, because DNA cannot move from outside the nucleus, so mRNA has to do it for it. So then tRNA, which is transfer RNA, carries amino acids to the ribosomes, so they can be used for proteins. It also has an anticodon. An anticodon is the complement to the codon that will be on the mRNA. So here's what it'll look like. We're going to have our mRNA, which I'm drawing for you now. See, those are all the different codons popping up there. That's the mRNA. So now the tRNA is going to come and it's going to match up because its anticodon will correspond to the codon found on the mRNA. Each anticodon is just on one tRNA. On top of the tRNA is the amino acid that we talked about earlier. So you see, tRNA's job is to bring the amino acid to the ribosome, and the ribosome can read that information to create the proteins. The proteins are linked amino acids, and they create polypeptides, and they're linked by dehydration synthesis. And there you have it.